Hey everybody, I am Jeff Spletta. I'm on the community team at Isovalent, and I'm doing today's U.S. Time zoned echo session for Cilium eBPF, and I'm going to talk today. I don't think we've ever done an echo session on specifically on the exposed Prometheus metrics that Cilium exposes. So I was going to do a sort of review of that as they look like now in the latest Cilium release of 1.17.1. But before I get into that, I want to review uh, the latest Echo News that Bill put together. Let me switch over to that. Let's see if I can figure out how to actually make a live stream work. There we go. There's actually Bill does a great job finding really interesting content out in the eBPF community. There's always a lot of interesting tools and projects out there. So I just wanted to highlight a couple of things. If you're not on the newsletter, sign up for the newsletter because it's just a really interesting overview of what's going on out the ecosystem, the eBPF ecosystem. So we have Isovalent has a new enterprise tetragon blog post out all about memory metrics there and auditing eBPF operations. That's on message for today a little bit. I actually find this really interesting, the two-phase eBPF program signing. I really want to spend some time looking at this repo. Let me see if I can punch into that. Yeah, there it is. So I find this really interesting because, like, for me personally, I've always thought of UPF programs as being sort of the new way to do kernel modules, and kernel module signing has always been sort of an interesting aspect of security for the Linux kernel. It was a big deal, sort of 15 years ago. When they sort of figured out how to do vendor signing, but the problem is with UPF, it's actually really hard to sign these things, right? So it's interesting to see how people are addressing this problem. So I'm looking forward to diving into that and trying to understand what this project looks like. So yeah, let's see what else is down here. So there is useful for exploring for eBPF nerds. Well, that sounds great. So list any Linux trace point and their arguments. That's a great learning tool, it looks like. And then in the ecosystem, there's a new case study from ByteDance from the UPF Foundation. Let's see. Oh yeah, the more on message for today. This video, another podcast talking specifically about observability and cloud native space, open telemetry, and UPF is actually pretty interesting. I think it has a good perspective of the journey the entire industry's been on from simple metrics into open telemetry, which structured logs, and now into eBPF as a way to get performant observability data. So as a follow-up to this, I think this observability talk is an interesting thing to watch after you are done listening to me. So take a look at the newsletter, and there's always a ton of stuff going on. But coming up, we have KubeCon Europe is around the corner, and I believe we have a Cilium Con event happening there. So that's probably the biggest thing everyone's preparing for. But for right now, let me switch off of this and I want to talk about Cilium metrics. If I can figure out how to actually There we go. Talk about metrics, um, observability metrics from Cilium. You know, we've talked some, I think in past echo sessions about Hubble and the service map, but not so much about the metrics capabilities from Cilium. So, oh, Tony did a comment on YouTube. Hello, Tony. I'll make sure I try to keep the comments open while I can and see if anyone has a comment about what I'm talking about and try to respond to it live. So, so let me show you. Let me switch back and share the screen. Uh, and start talking about it. So in the Cilium project documentation, there's actually do a pretty good job of providing documentation of all the available Prometheus metrics. And I sort of divide them up in my head in three categories, right? There is overall Cilium performance metrics, which you will want to integrate if you want to check for Cilium's actual performance on the host. So if you're start running into uh, system resource limits, or you can start tweaking the tuning on Cilium, right? So that you can stay ahead of the problem. Things like um, how big the maps are, because, for example, Cilium it's based on eBPF, so there's a lot of eBPF map usage to hold state, right? And so there are some default map sizes, but as you move into larger deployments, you have to tune those, right? And so and that's always a trade-off. Tuning parameters are always a trade-off, right? So these metrics give you the ability to track that, so you can alert on things like map pressure. And I'm going to show what that looks like in in a sort of hands-on. So that's sort of the first thing. There's also I think a newer metric type where they're starting to track in the metrics specifically which features are turned on the Cilium agents. And because Cilium agents can actually have different feature sets, because you can actually have per node Cilium configs. So you can get into pretty complicated situations where one node or will have an agent with one feature on, another node won't. And so you're able to actually keep track of that if you want to, as part of your metrics, instead of having to, especially for the advanced features. So I'll show you in the docs. Yeah, so there is, chaining, like when you're talking about data path, like whether chaining's enabled, you can keep up with that as a metrics value, which is interesting. There's also a whole bunch of booleans, and they come up as zero or ones as the value on a per agent node. So yeah, feature metrics, advanced connectivity and load balancing, control plane, data path. So for example, if you have bandwidth manager enabled on one of the agents or all the agents, you'll be able to see that in the Prometheus metrics, if that's something you need to keep track of in your environment. So there's feature metrics, but then there's also a third category, which I think of as metrics about your network. And for the most part, these are Hubble metrics that are very configurable, and they actually let you configure the cardinality to a great extent, which is, in my opinion, you can get into trouble there. So I'm going to show you that because like you have to be careful with cardinality, because you could ask for absolutely a little, like, tens of labels, but you don't necessarily need that on a day-to-day, and it can cause problems in your data store. Oh, what are the recommended metrics? Well, I think by default, Sherwood asked in the comment, by default, the Cilium operator has its metrics enabled by default, and I'll actually show you what that looks like in my environment. And so if we look at the operator metrics, operator metrics are on by default when you enable Prometheus metrics. And then you have to enable the agent metrics as a, if you desire them. So the operator metrics, there's a, let me roll over to my environment. I'll show you what it looks like. Let me share. So I actually have Prometheus running in a small kind environment, and we can actually do Cilium operator. And so we can actually see the, like the total number of pods observed, the number of IP addresses used in a given pool, for if you're using the IPAM pool. So all of the Cilium operator metrics are on by default, and they give us a good idea of just what the overall state of Cilium is, but not a particular resource pressure that an agent would have on a particular node. So going beyond this, if you look at what the agents expose, I think you will end up wanting to have things like the Cilium map pressure, because I actually think this is probably a good tool overall for as a diagnostic, just to see if your nodes have enough resources for the load you're asking for, right? Because ultimately all of the Cilium state, whether it's the networking policy or identities, ultimately are going to be expressed as BPF maps, right? And we want to make sure that you're not overtopping the capacity of your map. So the BPF map pressure is a percentage of the available maps capacity, and so this is the kind of thing that I think makes for a really good sort of strong signal on where you're at in terms of resource use, right? But that's overall how Cilium is operating, and depending on what features you have enabled, you may need other things from the agent. But I think as a baseline, the BPF map pressure is probably important. There's also the size of the memory it's being used, which can be a pressure point, depending on what your node provisioning is like. The other thing, and I think this comes down to in larger environments, once you have a lot of nodes, I think this is something that I think has been done. A lot of work has been done in the last couple of cycles around, especially the KV store mesh implementation, to make it possible to share state or rehydrate state faster across the entire cluster mesh of Cilium nodes at when a new node comes up. Right, there's a lot of thrashing when a new node comes up, because it has to basically reestablish state, especially in a cluster mesh environment where you have multiple clusters who are trying to coordinate with each other across policy and identities, right? And I think if you pay attention to the bootstrap seconds there, you can probably get a sense of when you're starting to approach problems, right? So those are probably strong signals to watch from an operational situation, as if you're scaling, right? Or if you're or if you're bringing nodes up and down, and you can see if you need to start doing some tuning there to make sure that you're not creating a bottleneck when nodes come up and down. But that's, like I said, that's for big clusters. I think everybody, even if you're running just a small cluster in testing, I think map pressure is probably the biggest the biggest strongest signal you can have that you're overtopping uh, your node provisioning. So I got ahead of myself a little bit there answering a question, but let me go back to let me try to go back to the page. So like I said, the documentation page that goes through all the available individual metrics. And so I've covered the operator. The operator has a set of metrics. The Cilium agent has a set of metrics which are more operational. But in terms of workloads, in terms of what your network's actually doing, Hubble also, once you have Hubble enabled, you can enable Hubble metrics. And these are the ones that I think can get you into some problems if you just turn them all on, because you can add a ton of cardinality here. Because to make sense of your workload statistics as metrics, you end up wanting to add a lot of granularity, and that causes a cardinality explosion, right? So, for example, and I think these are great features. It's just that you have to make sure you are not abusing them. For example, the Hubble metrics have the ability to have label context, where you can basically take individual pieces of the Hubble flow information, like what pod traffic is associated with, and or namespace or IP, all that information that would be in a Hubble flow and expressed in the Hubble UI or in the Hubble CLI tool output in the structured logs. You can turn those into labels, and then every label you add adds cardinality. So you can have 30 of these, or I guess it's like 10 different possible labels you can add, but ends up being in a very active cluster, ends up being a lot of individual time series, because every possible combination of label value ends up being in the time series database a separate time series which is useful, but also creates some problems in terms of data amounts. It just ends up being it can become inefficient to access versus just using the flows as structured logs in a data lake and then looking back at that to audit. So I would caution about using this and keeping it for long periods of time. It might be great as a short term, like live fire diagnostic, when things are on fire and you're trying to figure it out. If you have even 15 minutes of this in terms of time database retention, it might be okay. I did a talk at SREcon last year, actually, where I talked about this a bit. And, I think there's some great strategies out there where if you can make use of time series databases that have different retention policies for different metrics, you can build up sort of a catalog of metrics observabilities based on if you're in a live fire exercise where something is on fire, you got to diagnose it right now, versus your leading metrics where you need to trend and watch out for, so you can stay ahead of resource bottlenecks. And then there's audit, which is sort of 6 months later. That's where you need to start thinking maybe metrics isn't the right thing, and you need to go to the structured log so you can do more flexible queries, right, in sort of a historical record. So, but in terms of diagnosing something that's going right now, if the Hubble UI service map isn't enough information for you, you might be able to make use of these metrics with these context labels so that you can sort it out, right? But it will be part of your dashboarding journey to figure out how to make use of that. So I'm going to flip over to sort of an environment and just sort of show what that looks like. It's a really simple kind environment using the tutorial Star Wars service. But if I can, let's see if I can figure out how to actually stop sharing that screen and share my terminal window. I think I'm sharing. Well, we'll find out in a second. Why is it not? Am I sharing? That's interesting. I don't think I'm. There it is. Okay, it took a second for the streamer to show the terminal. So I actually have a little environment here spun up. It's a kind environment, and I'm going to show you the configs for it sort of slowly, so everyone who's watching this later can sort of play along. But this is Cilium 1.17. So by default, the Envoy is split out as its own daemon set from Cilium. I think that wasn't default before, but I think in either 116 or 117, that's now the default, where you'll now start seeing the Cilium Envoy daemon set next to the agent instead of being just a thread run by the agent itself. So, and that's used for things like the layer 7 network policy, or I believe the ingress and gateway API make use of this. But I'm not going to be using much of that features. I'm just letting you know, if you're used to Cilium from older versions, you might not have seen this because I think it's a new default. And obviously Cilium operator, I have Hubble relay and the Hubble UI running, so I can just make sure I have access to that in the environment. And yeah, and then 4 nodes, 3 worker nodes, and 1 control plane. Let's see if I can. Let me show you real quick what the config is, and for my kind cluster as I spun up, just for reference. So I did a pretty simple kind config. I disabled the CNI and I disabled qproxy so that Cilium can be qproxy. The initial Cilium config that I installed with Hubble enabled, Hubble relay enabled, and then I added as an upgrade with Helm metrics broken out. I have, let's see, I have Hubble metrics, I have DNS drop flow. I have for the HTTP metrics, I'm using the source context and the destination context right now. I'm going to, hopefully I'll have time, I'll flip on the labels context and show you what that looks like in terms of cardinality. But I also have, Prometheus enabled for the operator and Prometheus enabled for Cilium. So I should have all the metrics enabled. And let me show you what that looks like. I also have, from the documentation, I'm using the example Prometheus monitoring example config map, and this is actually from the docs, but we are making use of a pretty standard approach for Prometheus relabeling to discover which containers and which services are exposing our Prometheus metrics, right? So I'm just trying to find the config map with the relabel. Here it is. So yeah, the scrape configs, because we're using a set of annotation. This is pretty common across the industry. If you're not familiar with setting things up for Prometheus, the idea is that you can use the scrape configs so that you are looking for specific annotations, to tell it where the metric endpoints are. And in this case, we're going to end up using some service endpoints, and some headless services and some pods. So the idea is that it's pretty complicated, uh, because you end up doing some taking the source labels and basically re-plumbing them into the scrape configs. So if you enjoy reading regex, you will enjoy reading the scrape configs. I find it sort a little bit eye bleedy, but this is how you do it. So, but in practice, once you have that scrape config in place, um, Cilium actually annotates everything for you. So let me control get. I'm going to move something out of the way. Here we go. I'm going to describe the namespace cube system. Well, first let me get the pods. Get pods, because it's going to be on the Cilium pods that are annotated. So describe Cilium should work. So I have basically is telling the Prometheus scraper that this pod has a metrics endpoint at on port 9962, and it needs to be scraped. And that's how Cilium agents expose their port. But Cilium agents actually expose multiple metrics ports. We're actually exposing the Hubble metrics port too. And the way we get that is there's actually a headless service spun up just to point Prometheus to the right endpoints that it's annotated. So just to describe Hubble service. No, sorry, Hubble metrics. This is just plumbing. I just want to, for people who are watching this and aren't familiar how this works. So right here, this headless service points to a different port, but it's actually pointing to the exact same IP addresses as the Cilium agents. So really, it's the Cilium agents that are providing two different metrics endpoints, depending on whether or not Hubble metrics are enabled, as well as the agent metrics. So, and all of this just gets redirected via the magic of the annotation. So Prometheus can scrape those endpoints and do what it needs to be done. So let me show you. In fact, I should be able, I should be able to curl that, right? So if I do curl 192.168.228.65 metrics. There we go. So this is an example of the Hubble metrics that are being exposed. I just want to show you. I don't think I gotta see if I can find. I might need to run the. I might need to run the X-wing. Hold on. No, so let me do the instructions to actually have the TIE Fighter or X-wing land in the Death Star service that I have Just gotta never remember that right off the top of my head. Yeah, so if I try to do this, will fail because I have a policy in place that prevents the X-wing from landing. If you haven't done the Star Wars tutorial, I'm referring to the excellent network policy Star Wars tutorial, which is just my go-to when I building up any sort of demo. But the TIE Fighter works. So now let's see if that was from the correct. No. And that's fine because it could be I'm on the wrong agent here, because the different agents will have different statistics, right? The different metrics. There we go. So what's happening is the 2282 Cilium agent, that node, the TIE Fighter pod wasn't running there, right? So it's not going to actually see any metrics, but because the TIE Fighter was running on 2283, then it'll show up there. So let me, and I want to just show you, I'm making use of this source context concept, and this is definable. I'll go back. Let me show you the config, right? So I'm actually defining that source label to be the pod name, which is actually the namespace / the pod name. I believe if I go back. Yeah, so namespace default and then / pod name. And so there's actually multiple options for the source context and the destination. In fact, the destination context it'll tell me exactly which Death Star backend, even though the Death Star is a service, there are multiple backends. This will tell me exactly which, if I do it this way, it'll tell me exactly which destination pod for the service that metrics line is talking about. But, or in this case, that's a whole histogram, right? So by adding that, you end up getting granularity, but you get a lot more time series you have to keep up with. So it's important to keep that in mind. But it's a super flexible concept. So I wanted to make sure I covered it. Let's see. Let me flip over. That's what it looks like, raw metrics. Let me show you what the Prometheus interface that I'm running, because it has a simple query. I'm not going to get into the Grafana stuff. Let me stop sharing and I'll add the a comment from YouTube. The context labels are pretty complicated. In fact, that's why they're actually derived from the Hubble flows, and the Hubble flows as a structured log are probably easier overall if you have a data lake to ingest, and then you can use whatever query language that data lake is, like after the fact. This is really useful if you're building sort of, like I said, live fire dashboards, and you need to track stuff like right now. In the last 5 minutes, you're trying to diagnose an active problem. I think these metrics and this amount of granularity in the labels can be useful, but it's also, you have to understand your environment well enough to make use of. This is definitely an advanced feature. It's not something I would just tell people to turn on all the Hubble metrics and just get the fire hose. It'd be much better to just export the Hubble flows so that you can query the structured logs. And there's a whole debate in the industry, right, about we're now transitioning from being able to do simple golden signal metrics, which are still valuable if you can trend them, but then there's so much context in the structured laws. that you can make use of, that you may not want to use this as your primary means anymore, metrics as your primary means to get access to that much metadata, right? But if you can select a couple of pieces of metadata so that you just are keeping track of just the source and the destination, you may find value there inside of your sort of traditional metrics dashboards. So let me share the tab. Here we go. So this is just the what the I'm exposing the running Prometheus server, and it has a simple data query, so I can show you the Hubble. Yeah, so execute. So this is just the same thing I was looking at, and now I do like 50. Yeah, so just poke into this, you can see I have like, here's the X-wing status 503 because it's denied. Here is X-wing from a different, I believe it's going to a different backend. And then this is the TIE fighter that has status 200 because it's allowed to land. It's not knocked off by policy. In fact, I probably also have other stats here, right? I think the drops are available too. Hubble drop total. So if you can look at this, also has, I did not do the source context on the drop total. I just did it on the HTTP stats for right now. So here's a case where I don't have the source context associated with this particular metric. So this is just going to be the drop total at the agent by agent level. So we should have a couple of here for the two different agents that actually have had drops recorded in their flows. So I think that is mostly what I wanted to show. Oh, let me show you, if I switch to the label context instead of the source context, what happens. So if I want to update the config, so I want, instead of doing the simple source context where I'm saying just associate the pod to the destination and source labels, I'm going to do something way more complicated. I'm not using a service. I'm not using a service that has exemplar, so that first one doesn't really matter right now. But you can also turn sort of tracing exemplars into metrics data, so you can coordinate tracing information with metrics if you need it. But that's a super advanced feature. I want to use it this time. I want to use the label context instead. And here, instead of doing just source and destination, I now have source IP and source namespace and source pod and source workload. All of that separated out, and traffic direction. So now when those logs about the HTTP request, it'll tell me whether Hubble saw it as an ingress or an egress, because part of this matters what you're, especially for the layer 7 stuff, you have to turn on layer 7 enforcement in Hubble to get these metrics. So otherwise you don't have any visibility into HTTP or layer 7 until you've instructed the network policy to basically at least do something with anything with layer 7. So in my case, I have, let me show you what I have for policy. It's the really simple visibility policy. I have just to basically say, if DNS allow it, right, and then if it's port 80 or 80, basically allow any HTTP on that. So this is enough of a policy to basically turn on layer 7 visibility, and then that way Hubble metrics for the HTTP will start tracking those HTTP requests, at least if they're on port 80 or port 80, right? So it doesn't enforce, it just provides some, there's no drops there. The drops come from the other policy I added. Let's see, from the Star Wars example, get CP. Right, so I have just this rule 1, which is just basically preventing the X-wing from landing, as per the tutorial. So this is a layer 3, layer 4 policy, and it doesn't read on the HTTP metrics at all. But it does show up in those drop metrics that I showed you. The Hubble sees this as a drop, but it doesn't see this as impacting the request. The visibility policy is what ends up allowing us to see that the X-wing and the TIE fighter on egress ended up making an HTTP request, and then we get the status result back in those cases as part of the data in the as a label, right? So you can actually start splitting them up based on the return value in your metrics queries. Right, so let me, back to what I was doing. So let me actually flip over. So I'm going to use the Cilium CLI tool because it uses Helm behind the scenes now. Upgrade version 1, reuse. This will reconfigure Cilium to have a different set of labels now on the Hubble metrics, a lot more labels. And then I have to actually restart the agents. It's rollout. Start DS Cilium. This should, in a couple of minutes, come up. I try to prep as much as possible, but any type of live reconfig always creates a minute of dead time. I didn't. And so Cilium, I should point out, while you're restarting, the eBPF programs are still in place, so this actually doesn't disrupt network. We just need to have it reread the maps, the config maps, so that the agents can, when they restart up, they have the correct configuration like we want. So it's back up, and I should now be able to run some more landing requests. I'll just roll it back. Let's do TIE Fighter because it's not going to be blocked. Give it a second. There should be way more. I got to present the screen. Sorry. Let me go back to the Prometheus page. So now, if I do, hopefully, it's been long enough for a scrape to happen. So if I do Hubble request totals, yeah, now I have way more labels here. So instead of just having source and destination, I now have label context which gives me broken out source IP, source name, source pod, status, and I think the important thing is that all of that is pretty configurable in terms of how much label context you want. So let me show you in the docs. It's not, there we go. I must have, I'm bad at streaming. I wasn't sharing the screen. So the label context, I'll go back and redo it. I don't know if the streaming was correctly. So the label context, you have access to what? A dozen or so different labels. And so you can choose to only keep track of a few of them. And in my case, I'm doing, several, like source IP, source pod name, source namespace, traffic direction, which I actually think that's pretty useful if you're trying to use your metrics as to help you diagnose in a way that if you're not going to make use of the Hubble UI service map and you want to make use of your own custom metrics dashboards, the traffic direction and the status, right, are really useful there because that will help you know if which policy is catching this. Because if it's an ingress policy into like a service, right, this traffic direction will let you know that, right? So you're not hunting for the wrong policy if you're having a policy mismatch and you need to figure out what's impacted. This will give you sort of a breadcrumb to what to look for to address the problem if you're getting unexpected drops, right? So let me see if I do X-Wing now, I should get some status 503s. Just in the terminal doing a couple of X-Wing landings. It takes a second to scrape it. There we go. So now, yeah, here's my 503. So I have the X-Wing running. Traffic direction is still egress, so it's an egress policy that's stopping it, not an ingress policy. So that is sort of the example of the label context on the Hubble. So hopefully, I think that's where I want to wrap up. I'll see if there's any more questions. Yeah, I'm sharing my screen now. I'm sorry. Let me go back. I'll redo some things. So let me go back to my. I'll share the. I'll share the window. There we go. So I've changed it so that I now have all of these. I'm using the label context, and I've basically chosen which of the labels, a subset of the dozen or so you can add. And now, if I look at, I'll just look at it in the screen here. I should be able to go back to the same. Yeah, so now because I'm using the label context, I have many more labels, which means higher cardinality. The destination information is broken out, and the source information is broken out as I've asked for it. So you can track source pod and source IP, and like I said, the traffic direction I think is super useful because it gives you some indication of where the policy that ends up creating this metric is living. It's not an ingress; it's an egress policy. So that is helps you figure out when you're looking at this, if you're using your metrics dashboard, where in the Cilium policy list you need to try to identify the problem. So I think that's it. I don't want to go over an hour today, but if there's any other questions, but hopefully that was a useful review for you in terms of just where things are at with Cilium support for Prometheus metrics right now. Like I said, there's sort of three categories. There's that I think are useful beyond the simple Golang, the Golang stuff that every Golang program has, right? In terms of exposed metrics, but there's Cilium operator and Cilium agent exposes both sort of diagnostic, sort of trendable metrics about where how resources are being consumed and that you can trend. Like I said, the operator keeps up with things like your IP pools, so you can see if you're getting close to using up all of your available IP addresses in the configured pools. If you're using Cilium's, IP load balancer internal IP pools. The Cilium agent exposes things at node level that you need to be concerned about, things like map pressure or map memory use, so that as that trends up and you see you're getting map pressure, you can make some decisions about tuning or maybe moving to a larger node in terms of resource capacity, so that you don't overtop the maps. The maps, that's when you start having scaling problems. So you want to keep up with that, right? So those are the sort of the golden signal things that you can trend. There's also those new, I think they're pretty new metrics that expose whether or not certain features are on. That's super useful because, like I said, individual Cilium agents can have per node configurations. It's not what you see in the simple testing environments like we have in the tutorials, but in a cluster built in Anger, you may have a need to basically have kube proxy on some nodes, and some others you don't, right? And this is a way to keep up with that. So as you're spinning nodes up and down, you can figure out what's going on without having to go into the Cilium configs for each one, right? So something to think about there in the complicated environments. And then if in terms of workloads, metrics associated with your workloads, it's all about the Hubble metrics, and those are configurable in a way that, like I said, a lot of flexibility in terms of how you design which labels to keep up with, but the trade-off is cardinality. And I like to think about that as, if you're actively diagnosing and you have a dashboard set up that you want to integrate with, make use of time boxing, how long you keep those around, so that you don't have an explosion of high cardinality data. You can keep those just for as long as it takes for you to diagnose an active problem, and then rely on the archive of Hubble flows in your data lake for more of an auditing purpose. I think that's probably the best trade-off between high cardinality metrics as metrics versus high cardinality in terms of structured logs for long term. So I think that's everything. Hopefully this was useful, and like I said, this should give you a starting point so you can play around and start getting used to how to use the Cilium metrics and see if they make sense for you and your workflow. So I think that's it for me. Thanks for hanging out. I'm going to sign off now, and hopefully, I think next week maybe there's a Cilium 117 cap. I'm not sure. I don't quote me on that, but I think we're gonna review sort of a top-down review of what's in the new Cilium release that came out like last week. So stay tuned for that. Okay, thanks everybody.